When do you find out that there's something wrong with your application or some of your services? Do you get plagued by users actually telling you this, that there's something wrong? Have you heard about the Health Endpoint Monitoring Pattern? Well, stay tuned because that is what we're going to be talking about today here on Cloud with Chris. Hello there and welcome back to another episode of Cloud with Chris. You are with me, Chris Reddington, and here we will be talking about all things cloud. Now thank you once again for joining another episode in the series of Architecting in the Cloud, one pattern at a time. And in this episode we will be talking about the Health Endpoint Monitoring Pattern. So as we mentioned in the intro there, we're in a world now where our users are expecting a lot more of the solutions that we're building. We can't wait for them to tell us that something is wrong. We need to be on the front foot. We need to understand that when there is something wrong, what is wrong, and how we go and fix that. So that is where the Health Endpoint Monitoring Pattern comes in, and that is what we'll be walking through here. So if you think about the scenario, you've got maybe one service, a website and a back end, for example, and you want to find out if the website is okay and running healthy, or whether, the APIs on your back end or the SQL database is running healthily. How do you do that? Well, that is exactly what the Health Endpoint Monitoring Pattern is trying to achieve here. There are many problems that could arise from a cloud application and cloud architecture. It's not just about one particular component going down. It could be some kind of degradation of service. It could be the fact that a endpoint is unreachable, for example, or it could be that your VM has gone down, for example. Any number of different scenarios. And really, the idea behind the Health Endpoint Monitoring Pattern is that you go to some kind of endpoint and you say, "Okay, application, are you alive? Are you running? Is everything okay?" And if everything is running okay, then you get a successful response back and it says, "Yep, everything's good, all okay." If everything isn't okay, then it says, "Sorry, there's something wrong." Now, there are different ways that you can go and approach this, and we'll look at this in the context of this pattern here. It might be, for example, that you have a binary yes, no, everything is working as expected, we're able to connect to the database, everything's fine. Or you might add a little bit more logic and a bit more, intelligence, let's say, behind your solution. And you might go ahead and say, are certain responses coming back in a certain amount of time, under a certain amount of milliseconds. So that's where you can really start building some intelligence under whether the system is performing as you would expect. So it does require some background on, do we know how the system is actually going to run and how it should perform? So the context of this pattern then, the problem, if we think about, as we mentioned, a single web application or even a set of microservices, are they all available? Are they all performing correctly and as expected? Now, because we've got this distributed world, it's hard for us to monitor all of those different services in one place and get this aggregated view. That is really what we're talking about here with this Health Endpoint Monitoring Pattern. So if we look at the solution, it's very similar to what I just described a moment ago here. The idea is that you would have an application performing a series of health checks on some of those back-end services. So is our storage layer working correctly? Is the database layer working correctly? How about microservice 1, microservice 2, microservice 3? If you're in a microservices world, you might have a database per microservice, in which case those microservices are giving back a Health Endpoint Monitoring Pattern. So you call microservice 1, it's checking its storage, it's checking its database, it's checking its back-end workers, for example, if they're all working as expected. And that's really the idea behind this Health Endpoint Monitoring Pattern. You aggregate the view and you can get this intelligent response around, is it working correctly and as expected or not? It's not just a binary yes, no. It could be we're getting a response within 5 milliseconds or 10 milliseconds or 20 milliseconds. So we need to flag that as a red, amber, green scenario, for example. Things are healthy, there's a warning, or there's an error. So you can really factor that into how you like and how it makes sense for your application. And typically the way that this works is you will respond using HTTP status codes. So if everything is good, then you send an HTTP 200 status codes, just like we normally would when we serve up a good web page. But there might be other response codes that we send back depending upon, whether something bad is happening. And you don't just have to send the response code back. You could send, as I've seen in some .NET implementations, for example, some JSON back with some of those individual pieces. So the database is unavailable. The database response time is 20 milliseconds, whatever it may be. So you can then be granular in sending that back to the client and visualizing what that response actually looks like. Are there certain components which are not working? Or are there certain components which are working and everything is okay there? So it's not just limited to performance. You could do things like checking for security, so checking SSL certificates. You could do things like measuring response time of DNS calls. There are a number of different ways that you can obviously go and do this, and ultimately the culmination of that is you could have some kind of dashboard of those various health endpoints then. So monitoring it on a service by service basis and understanding, are there certain services which are being impacted? And that then allows you to understand, does one service start causing a cascading failure across your application there? So actually this is quite an intelligent way to monitor. It's not really something that we're talking about from an underlying infrastructure monitoring perspective, but really building it into the application level and having that richness and understanding of the components and the bringing together and the combination and the augmentation of our application. So let's now think about the issues that might arise with this particular solution, this particular pattern. So we've talked already that we could be as simple as binary yes, no, this is working, this isn't working. How deep do we need to go? How deep do we really need to understand what is working, what downstream services or upstream services are working as expected, which ones are not working as expected? How granular do we really need to go? And that's the first decision you'll need to think of. And then combined with that, how do you compose your health endpoint monitoring endpoints? So are there certain scenarios where you might want to have each microservice having its own health endpoint, or do you want an aggregated view of the entire system? And thinking about how you go and compose those together. What type of information do you want to go and serve up? Because of course, if you're serving certain information back, could that be used in a malicious way to attack the system? If people know, for example, that latency is increasing on your database, is that something an attacker might go ahead and actually use to their advantage, for example? You always need to think about those threats, how could they be turned against you there? And then if you think about scenarios like Office 365 or Azure DevOps, GitHub, several of those big kind of cloud platforms and cloud services, they will have something available like a dashboard of what regions are healthy, what services are healthy, where there may be issues, for example. And one of the things to think about in a scenario where something is wrong is a lot of people are going to start hitting that endpoint, hitting that dashboard. And if it's actually querying that health endpoint monitoring endpoint, then that's going to be adding extra loads to your service. And depending upon what that endpoint is doing, how much intensity it's doing in terms of querying your databases, checking your APIs, it might be adding extra load, which is just compounding the problem that you're seeing. So caching is something you need to consider. But again, how much caching is too much? And again, that is something in the context of your solution and your application you would need to go and consider. And that really goes for things like denial of service then as well. If we think about really extrapolating that point further, could someone go ahead and potentially launch a denial of service attack against you because you're querying so many of the different components and subsystems of your service? Again, compounding that problem. That's something you'd want to go and think about. Okay, so when to use this pattern? Well, hopefully it's very clear. If you need to go and monitor for availability or checking that everything is working operationally as you would expect, if you want to be able to understand the kind of middle tiers and the back end tiers and whether they're healthy in the context of a particular service or a context of a particular component, those would be good examples. But one example we haven't particularly talked about yet is this idea of being able to kick off certain monitoring tasks or certain tests or certain diagnostics, for example. Those could be examples of the Health Endpoint Monitoring Pattern. So you call this URI, maybe it's secured in some way using a JWT token, some kind of access control and restricted there. But then what you could do is you could make sure that it's validating, are we able to go ahead and create a new order in our shopping basket? Are we able to go ahead and perform that user deletion step? Are we able to go and clean up that user data or launch that background task? Just being able to validate, not just is it up or down, but is it then able to actually go ahead and launch that business functionality that we're expecting as well? So we're not going to go into the deep details of the kind of code samples here, but there are examples in the Azure Architecture Center if you want to go and take a look at how you could go and implement this type of pattern. And there are third-party frameworks, tools, for example, that also implement this type of pattern. So definitely go ahead and check those out as well. So this isn't a replacement for the built-in Azure monitoring tools at all. Things like Azure Monitor, things like Application Insights. Like all of these design patterns, it's more of a theoretical pattern. It's a way of approaching monitoring. So you could absolutely use these in combination, whether you're using those Azure services or third-party tools or things like System Center and that suite of tools and suite of products. Those are all different things that you could go and consider using. Now, ultimately, like any kind of monitoring discussion, what you actually want to go and monitor is going to depend on the type of system. So if I'm running a big financial system, I'll probably care more about the fact that my latency and the time that it takes for me to process my transactions, for example, is very low compared to, let's say, I don't know, a monthly batch job that runs, and I want to make sure whether that's just binary up or down, not necessarily the response time of some of those transactions and how long they take. So the context, once again, is going to really depend upon your application, your solution. So don't go entering first thinking you need to solve every single problem. Start thinking about the questions that you want to go and ask that you want answered. So are we seeing all of the transactions, for example, being returned under a certain level of latency? Are we able to handle a certain amount of load? Is this particular microservice app, is this batch job able to run successfully right now? And once you start figuring out those questions, those are the requirements that you want to build out, then you can figure out what monitoring patterns you want to go and build into your solution. So there are, of course, other things that you could go and learn on top of this, making sure that you're well versed in Azure Monitor, Application Insights, and those suite of products if you're using the Azure monitoring tools. Otherwise, of course, the third-party equivalents as well. And making sure then that your operational side, you're able to react to whatever comes out of this Health Endpoint Monitoring Pattern. So it's all well and good being able to say, we've got a problem, but how do you then go and deal with it? What is then the next step? Who takes ownership of that? What is your operational process behind dealing with that? So there we go. That is the Health Endpoint Monitoring Pattern. So another of our architecture patterns in the Architecting the Cloud, one pattern at a time there. So you can see where this pattern is valuable. Trying to understand what is going on in our application, in our solution, on a service-by-service basis, and bringing those various components together in this distributed world into this single view, then being able to go and act upon it and reason upon it in a way that makes sense to our solution. So there we go. I hope you've enjoyed this episode. You know what to do. If you've liked it, please go ahead, hit the like button. And if you're not subscribed yet, please do consider subscribing to the channel and hitting that notification bell so that you know as soon as I push up some new content there. And of course, I'm doing this for the community. So if you listen on YouTube, if you listen on Spotify, whether it's Google Podcasts, Apple Podcasts, or cloudwithchris.com, please do consider sharing it, because the reason that I'm doing this is to help the community just understand a little bit more about some of these cloud design patterns, a little bit more around DevOps and all things Azure as well. So with that, all there is to say is thank you for watching, thank you for tuning in, and until next time, bye for now.